So WebEx has this annoying thing where if nobody joins your meeting, even though this is how I'm recording this, if no one joins your meeting, it has like a timer that will shut it off. And if you don't catch the timer, it'll turn off your meeting. But it looks like we're okay. All right, so I'm gonna start back over at mass at the kilogram to gram because that's where I noticed the camera fell off, and I think I should be able to trim and edit the videos and put them together. Okay. So we're at half a kilogram to gram. So 0.5 kilograms, and we want to turn it into grams. Now I know that grams are right here, right? That's the gram. And it takes 10 to the, that's 10 to the 1, 10 to the 2 is 100, 10 to the 3, that's 1,000. So it's going to take 1,000 grams to make 1 kilogram. If I have half a kilogram, I probably have half 1,000. But let's do the math anyway. So 0.5 kilograms over 1 times our conversion is then going to equal grams. I want to get rid of kilograms, so I'm going to put that on the bottom. I want to convert to grams, so I put that on the top. Then I just specify, okay, how many grams are in a kilogram, or which number is bigger. There should be 1,000 grams in 1 kilogram, which equals 500 grams. So that was right. Okay, next problem. That one is pretty easy. Let's do the next one. 7.4 micrograms is equal to, we got to convert that to nanograms. I got micrograms, I got to convert to nanograms. So if I have 7 of these, I probably have like thousands of these, right? So I know that this number will be bigger. Okay, so let's do our conversion. 7.4 nanograms. Do our conversion into nanograms. I didn't give myself a lot of space there. Equals nanograms. Okay. So we want to get rid of micrograms and we want to keep nanograms. So I'm going to cross those out. And then I just need to figure out, okay, how many nanograms are in 1 microgram? It looks like 10 to the 1, 10 to the 2, 10 to the 3. So that's 1,000. There'll be 1,000 of these in one of those, in one of those. Okay, so then I get 7.4 times 1,000 is 7,400. Cool. All right, next problem. Is 3.6 grams to kilograms. And we want to convert that into kilograms. Well, 3.6 grams isn't a whole lot. It's a couple of paper clips, and a kilogram is quite a bit. So I'm guessing we're not going to need very many kilograms to make this. So we're going to need less than 1 kilogram. I know that. So it's going to be 0 point something. And what that number is determined by our conversion. So let's take 3.6 grams over 1, multiply it by our conversion, is equal to something in kilograms. Okay, I know I want to get rid of grams. I know I want to keep kilograms. I know kilograms is the bigger number, so I'm going to put 1 there and figure out how many grams go into that. 10 to the 1, 10 to the 2, 10 to the 3. That's 1,000 grams in 1 kilogram. Cool. So then I'm going to take 1 kilogram, or 1 over 1,000, multiply that by 3.6, or take 3.6 divided by 1,000. So I can do that down here, just kind of on my scratch paper. And if I'm going to divide by 1,000, that's going to be 3 zeros, right? So I'm going to have to go 3 decimal places to the left. 1, 2, 3. There's my decimal, there's my 0, there's my 0. Okay. And then I'll put a 0 on the other side of the decimal to make it look pretty. So then I get 0.0036 kilograms. You might be looking at this and you might say, hold on, you divided by 1,000, why are there only 2 zeros there? Remember that in order to jump on the other side of that figure, I had to divide by 10. And then so that lost me one of the zeros, and then those 2 count for those 2 zeros. Okay, next problem. All right, let's continue on. We just did 3.6 grams. Let's do 8.7 nanograms. So 8.7 micrograms is equal to something milligrams. All right, like I said, let's just do our conversion. Micrograms over 1 multiplied by some conversion is equal to some number of milligrams, right? Okay, good. I see myself. All right, so we got micrograms on the bottom. That's to cancel out. And we want to put milligrams on top. Now we just have to figure out milli to micro, right? Which one's bigger? Milligrams seems bigger. So I'm going to need 1 milligram and talk about how many micrograms are in it. So there's 1, 2, 3. 10 to the third power is 1,000. Okay, and cross out our micrograms. So 8.7 divided by 1,000. I'm going to come down here and do the same thing I did, 8.7. And then we're going to go 3 decimals to the left. 1, 2, 3. That's dividing by 1,000. And that gets me 0.0087 milligrams. Cool? All right, let's go into liters. So volume, you guys can pause that and do the rest in that category. And let's go to volume. So I got 4 milliliters is equal to how many microliters? So I've got milliliters to microliters. Cool. Now let's see if we can do these in our head. We might be able to. Okay, so I have 4 milliliters. I know that's 4 of these is a lot of those. So let's see how many of these is 1 milliliter. I know 10 to the 1, 10 to the 2, so 10 to the 3. So there are 1,000 microliters in 1 milliliter. Well, shoot. And if I have 4 of these, that means I have 4,000 of these. So I have 4,000 microliters. Okay. Let's see the next one. We'll go nanoliters to milliliters. And if you want to pause them and do them on your own, that's fine too. No big deal. So we'll go 7 nanoliters is equal to milliliters. So I want to go from nano to milli. Well, shoot, you guys, that's a big jump. 7 nanometers is nothing. That's so minuscule. That's like a couple of water molecules. If you're weighing this, if you're doing this in water, you're wondering how many milliliters that is. Like milliliter is something visible. So something invisible, I'm going to need a lot of that. And so that's going to be a fraction of 1 milliliter. And so what I need to say is, okay, well, how many nanoliters are in 1 milliliter? Well, let's count. 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. There's 1,000,000 nanoliters in 1 milliliter. So that means I need to chop up a milliliter into 1,000,000 pieces and then take 7 of those and represent that in a decimal. So I could do it like this. I could say, okay, we start with 7. We start with 7. And I know I need to chop this into 1,000,000 pieces. So I need to move this decimal 6 places to the left. 1, 2, 3, 4, 5, 6. And I'll put a 0 on the other side of it just for good measure. Okay, and then I'll fill in where the U's are. I'll put a, so we should have, yep. So we've got 1, 2, 3, 4, 5 zeros now between the decimal and the 7, which is good because we were on the other side of the 7. That's where that 6 0 comes from. All right, so that's my answer, 0.000007 milliliters. Okay, next. Let's do. I'm sorry, bud. Do you need help? Yeah. Oh no, it was just the headphones when it hit the unpause button. Oh, okay, I gotcha. Into liters. This will be my last one for this one, and then we'll go into the practice problems. Okay, milliliters to liters. Okay, I'm gonna do this in my head. milliliter to liter. So I gotta take this. I have a smaller unit. I want to know how many of the bigger unit it is. So that means I'm gonna have to divide by, because now I'm going backwards. So I'm gonna divide by 1,000, right? 10 to the 1, 10 to the 2, 10 to the 3. So I'm dividing by 1,000 to figure out how much of a liter that makes up. So it's basically saying if I took a liter and split it into 1,000 pieces, right? How could I represent 3.8 of those pieces in a fraction or a decimal? And so what I'm going to do is I'm going to take 3.8 and I'm going to go backwards 3 zeros, which is how many are in 1,000. So 1, 2, 3. That's me chopping. That's me chopping it into 1,000 pieces and representing that in a decimal way. So 0.0038 liters. Cool. So that's the conversions there. Now we'll do some practical applications. Don't forget to take pictures of your tables and your charts and your work, because you'll need to submit that on Canvas. All right, so it says the naked eye can see substances as small as 0.2 millimeters. An algae cell is 300 micrometers long. How long is the algae cell in millimeters? And then would you be able to see it with the naked eye? All right, well, let's look. We can only see things that are 0.2 millimeters, 0.2 like that, right? They're giving us something in micrometers. I need to convert this to millimeters in order to see if it's more or less than 0.2. So what I'll do is I'll say 300 micrometers, multiply it by some conversion is how many millimeters? Well, I want to get the units in millimeters and I want to get rid of micrometers. So we do that real quick. Then I say, okay, there's 1,000 micrometers in 1 millimeter. So I take 300 and divide it by 1,000, or I take this decimal and I go 1, 2, 3 places to the left. Then I get 0.3 millimeters. Which one is bigger? So I would be able to see that. That's the answer. I would be able to see it with the naked eye. All right, this one's kind of a crazy story, but it's kind of funny. So unless you know Debbie, and then you're like totally shocked at me laughing about that. But I don't know anybody that knows Debbie. But Debbie Lane of Tempe went to Desert Samaritan Hospital and get a radioactive trace of her thyroid. That's something that you would really do. She drank the sample and it moved into her thyroid. The doctor prescribed her a dose of 100 microcuries. But what she got was 100 millicuries. Couple of questions. Which one is stronger? Well, this is what was prescribed. This is what she was given. So she was given something 1,000 times stronger. That's not good. So definitely what she got was stronger. How much stronger was it? Well, how many times do you have to multiply by 10 to get there? So 10 to the 1, 10 to the 2, 10 to the 3. So she got a dose that was 1,000 times stronger than the actual dose. And then what do you think happened to her thyroid? Well, I'll leave that up to your imagination. Next question. A doctor says you should take 1 gram of cholesterol-lowering medication per day. You've heard my spiel on that. Anyways, unfortunately, the pharmacy is out of 1 gram tablets. However, they do have 250 milligram tablets. How many pills would you need to take to get 1 gram per day? Well, we need 1 gram, but we need to know what that equals in milligrams, right? So let's convert. So 1 gram multiplied by some conversion is equal to milligrams. Okay, so I want grams on the bottom, milligrams on the top. I know that 1, 2, 3, it takes 10 to the 3rd power of milligrams to get 1 gram, and then my units can cancel. So 1,000 milligrams is what I need. How much is each pill? 250. So I need to take 1,000 milligrams and divide it by 250 to know how many doses to take. So I need to take 4 doses. 4 doses. Okay. Let's answer that question. Next, a flu vaccine. Okay, so you get 1 liter of coronavirus vaccine. A dose of this vaccine is 2 cc's. How many people can you immunize? Not enough, apparently, for the world goes to hell in a handbasket, but we'll do the best we can. Okay, 2 cc's. Well, we got to convert liters to cubic centimeters. 1 cubic centimeter is a milliliter, and so that helps me here. So I want to go from 1 liter to cubic centimeters. So I'm actually going to have to do 2 conversions, but this is a good chance to talk about this. So we want to go from 1 liter over 1. We want to convert that into milliliters, right? And so we're going to go put milliliters on top and liters on the bottom. We know there's 1,000 milliliters in 1 liter. And then to get the next conversion, I need to go to cc's. So I'm going to put cc's on top because that's what I want to get to, and milliliters on the bottom. And then that should give me cc's. So we're 1 cc and 1 milliliter. Wow, that was easy. Okay, liters cancel. And now I got my units of cc's. So what I really have is I have 1,000 cc's of flu vaccine. Now, 1 dose is what, 2.5 or something, or 2. So 2 cc's is 1 dose. So how many doses can I get out of 1,000? 500 doses. There you go. All right. This one's kind of sad and obscure. It's you have to be 1 meter tall to ride Legoland Jungle Safari ride in Europe. Your son's 125 centimeters. How tall is he in meters? So convert to meters, and then can he ride the ride? Well, let's take a look. If he's 1 meter tall, dude, he's not going to Europe. Nobody can travel right now. You might be able to get into Legoland, like down at the mall. Where is that? Off the I-10 over there. Mills, Arizona Mills. He might be able to go to that Legoland, but we'll see. So anyways, we're converting 1 meter. We need to get him into centimeters. So I put that on the top, meters on the bottom. Meters cancel. Oh wait, I'm converting, sorry. Oh yeah, okay, that's fine. I can do it this way. So there's 100 centimeters, right? There's 10 to the 1, 10 to the 2 in 1 meter. And that gives me 1 meter is 100 centimeters. My son is 125 centimeters. Okay, well, he's tall enough to ride the ride, okay? But I forgot to convert this to meters, so let's go the other way. 125 centimeters multiplied by our conversion, we want to get to meters, so we put 100 on the bottom, right? That's our 10 to the 1, 10 to the 2 is 100, so we put that on the bottom. And then we get 1.25 meters. So yeah, he's tall enough to ride that ride. Yeah, so take a photo of that page. And let's just do a couple of the scientific notation problems before we go. So I'm just gonna do like I'll do A and B or something for each one of those, and then we'll be done. So standard notation, I've already talked about this. Or scientific notation, I've already talked about this. If you have a number like 5,317, and we want to turn that into scientific notation, we can imagine that there's a decimal point and a 0 there, and that's going to help us. So what I want to have ideally in scientific notation is I want to have one number to the left of the decimal, followed by the remaining numbers to the right of the decimal. And so my question is, well, how many places am I moving this decimal to get to where I want it, to get to where it's like that? Well, I'm moving it 1, 2, 3. Well, that means I need to multiply it 10 to the 3rd power. It's that simple. Okay, so I'll do another one for you guys. And then we'll do a few questions. So let's say I have like 12,472. Okay. And I want to turn that into a scientific notation. I got to put a decimal and a 0. And then remember, I want to get one number to the left of the decimal and then the remaining numbers to the right. And I got to count how many times I do that. So I go 1, 2, 3, 4. 4 decimals will put it there. So I multiply that 10 to the 4th power. Okay, let's do the problems. A couple of the problems there. So we've got 234. Well, we can imagine that's 234.0. We want it to read 2.34 times 10 to the something, right? 10 to the 1, 2 power. We'll put it there. Okay, that's the first one. The second one, we're going the opposite direction. This will be a good one to review. So 0.0037. And we want to turn this to scientific notation. Well, it's the same idea. We want it to still read one number to the left of the decimal and then the rest of the numbers after it. And I just ask, okay, how many times do I have to divide by 10 to get there? 1, 2, 3. So I multiply by 10 times the minus 3. Because the minus 3 is going to move the decimal that way. Plus 3 is going to move it that way, right? So we're talking about, it's the difference between a fraction or thousands and millions, right? So are we dividing it into thousands and millions of pieces, or we got thousands and millions of parts? And that's what this decimal does. Okay, next problem. So let's go to the other side. It asks us to convert 8.35 times 10 to the 4. Well, when we multiply by 10 to the 4, that's how many times we move it to the right, because that's a big number. 10 to the 4 is like 10,000. So we're multiplying 8.35 times 10,000. So we'll probably get somewhere around 83,000, I'm guessing. So let's figure this out. 1, 2, 3, 4. That's how many places to the right I'm going to move. I'm going to need 2 extra zeros there. So 8, 3, 5, 0, 0. Right, because I started here and I went 1, 2, 3, 4 places to the right. The decimal, right? 4 places to the right. That gives me 83,000. Next problem, we'll do 5.87 times 10 to the minus 3. 5.87 times 10 to the minus 3. Yeah, same idea. This time I need to say, okay, I'm dividing by I'm dividing by units of 10. So I need to go backwards 1, 2, 3 decimal places back, fill it in. That equals 0.00587. And you can see this 10 to the minus 3, because if you go 1, 2, 3, you're back to where you started, 5.87 times 10 to the minus 3. Cool. I hope all that made sense. Good luck finishing this up. I will see you guys on the next one. Oh, this is on the floor. Okay.